Hello, we are L&T Precision Engineering and Systems. Our topic is IoT-enabled futuristic welding, reducing human fatigue and carbon footprint. Our team name is Visheshya, which means special in Sanskrit language, has successfully achieved efficiency in work and addressed sustainability issues. L&T is a professionally managed multinational EPC, which comprises multiple business verticals across many domains. Some of them are infrastructure, energy, high-tech manufacturing, information and technology, financial services and many more. L&T is majorly held by public institutions and has generated revenue of $26.7 billion United States dollars in financial year 2024. L&T Precision Engineering and System IC is located across pan-India locations. Our team is from Hazira, situated in Gujarat state, which is the largest manufacturing plant of L&T in India. L&T contributes widely to the social and governance causes, adopting various practices in order to uplift the community at large. We are also targeting to be water neutral by 2035 and carbon neutral by 2040. Thus, representing our commitment towards our vision of building a sustainable environment. We have targeted 3 sustainability development goals by executing this project, which are good health and well-being, industry innovation, and infrastructure and responsible consumption and production. L&T Precision Engineering and Systems IC is a high-end manufacturer with dedicated state-of-the-art infrastructure. We had received a significant order to manufacture a megastructure, whose weld quantum is equivalent to 15 adult elephants, comprising a total weld length equal to 14 Olympic track lengths. The T-ring vessel stiffeners are the main load-bearing members of the structure. The major task here was to perform welding of vessel stiffeners. Using the conventional method of manufacturing for 200 stiffeners, we would have required 1,650 days. This may have caused issues like dimensional inconsistency, high manual interventions, high probability of rework, and delivery delays due to non-value-adding activities like chip-back grinding and the requirement of highly skilled manpower. The core target for the team was to obtain necessary customer approval for the implementation of a new methodology and reduce the cycle time by 30%. The constraints of the manual method of manufacturing are: inconsistent weld deposition leads to abnormal tilt and distortion of the stiffeners. Root gauging is essential and leads to a higher cycle time. It requires back and forth turning to perform sequential welding on both sides of the T-joint. Hence, day-to-day productivity targets cannot be achieved. Performing preheating using gas burners consumes more energy. Skilled welders are required to eliminate chances of rework, hence process de-skilling is not possible. It is also not possible to control the process remotely with manual welding. This leads to the emission of harmful weld gases. Continuous preheating carries the risk of gas explosion. The manual method of welding exposes workers to UV radiation. The involvement of physical presence may lead to human injuries, and higher operator fatigue due to continuous contact. Attending all these issues was a complex task. To cater this in a structured manner, we adopted the PDCA approach. In plan phase, we used QC tools like Pareto, Gantt chart and brainstorming, which enabled us to focus in the right direction. Further, tools like ABC analysis and responsibility matrix narrowed down our interest. In do phase, we used tools like 5W+1H analysis to find out limitation of seam tracking. Fishbone diagram was used to identify root cause of weld shortcoming. YY analysis was used to eliminate concavity and reinforcing welding requirements. Phi analysis was implemented to validate the structural design. During check phase, we measured the NDE performance and progressively performed mock-up trails. We had also performed process capability analysis to ascertain performance of our proposed solution. Under the ACT phase, we had prepared standard operating procedures and processes to sustain best practice to be followed. Our team focused on reducing carbon footprint and minimizing human fatigue. We identified challenges with gas metal arc welding and, after extensive brainstorming, designed a special-purpose machine with advanced features to address these issues. This machine is known as Twin Head Tandem Gas Metal Arc Welding System. Let us see the reasoning behind this name and delve into the unique capabilities it offers. The entire system is designed by in-house team of Larsen and Toubro. Aligned with the UN Sustainable Development Goals, this special-purpose machine features a twin-wire process to increase deposition rate and reduce cycle time. It has a spider arm fixture for handling large objects up to 12 meters in diameter with precision and safety. Additionally, it includes a 2D laser tracking system and HD cameras for remote monitoring, enhancing precision and protecting operators from UV radiation. This system features a dedicated control cabin for remote operation by a single operator, enhancing safety and comfort. Advanced analytical tools streamline monitoring and decision-making. To reduce carbon footprint, an electricity-based infrared heating system replaces traditional gas methods, aligning with UN SDG objectives. Automated cutting and grinding processes further improve safety and efficiency by eliminating manual intervention in hazardous tasks. L&T is proud to be the first in India to develop such a unique and advanced system. Given the significance of this innovation, it was crucial to meticulously develop and fine-tune its welding parameters. We had demonstrated the entire system in front of customer. We are pleased to share that this system was successfully approved, receiving high praise and commendations from the customer for our innovation. On the left, you'll see two separate robotic systems performing simultaneous welding to avoid hazardous grinding processes. On the right, a flat position welding setup is significantly boosting productivity. The entire system can handle and rotate large objects within minutes, hence dramatically reducing human effort. It is important to highlight once again that the system is operated remotely, minimizing human fatigue and protecting operators from harmful radiation and gases. As mentioned earlier, there were 12 challenges which were to be tackled. These challenges can be put into 3 different categories. Each category signifies an UN Sustainability Development Goal. Goal number 3, Good Health and Well-being. Goal number 9, Industry, Innovation and Infrastructure. Goal number 12, Responsible Production and Consumption. With the aid of QC tools and other techniques, solutions to all 12 problems were identified and implemented. Number 1. Tilt and distortion control was achieved by using spider fixture with bevel springs to cater the weld shrinkages. Number 2. Chip back grinding was eliminated by implementation of twin head welding. Number 3. Turning and lifting is a huge non-value added activity which has been eliminated by using multi-axis manipulators and positioners. Number 4. Weld kilogram deposition was doubled and productivity was enhanced by using tandem welding arrangement with 2 wires in leading and lagging position. Number 5. Consumed energy was generated by solar and wind renewable energy alternatives. Number 6. Harmful gas emissions were avoided by using infrared-based heating. Number 7. Complete system was remotely controlled by a C cabin with operation consoles. Number 8. Deskilling of complete process was done by using robots with customized programs. Number 9. Fire and explosion hazard was avoided by using electrically operated infrared heating. Number 10. Ultraviolet exposure was prevented by using 2D laser sensors and motor drives. Number 11. Human injury was prevented by caging and digital and physical interlocks. Number 12. Operator fatigue was avoided by implementation of SCADA system. Overall business impact is 0 incidents throughout the journey, 99.94% FTR in quality, 60% cycle time reduction in productivity, 12.31 million rupee saving in cost. All jobs delivered well ahead of schedule. 463 metric ton of carbon footprint was eliminated in ESG. The credibility of L&T Precision Engineering and Systems IC Hazira can be seen in this picture. L&T PESIC has been bestowed with 52 international and national accolades. Thank you.
And thank you for the presentation and the application. Just looking at my who remembers now for a 5 minutes questions. Anyone have a question? If not, I will start with my question. There's mention about reduction of CO2, and I think you in the video also you showed wind and solar energy as being used. However, I thought this was that you reduced it through buying your energy from other sources. Is that a correct interpretation of myself?
So good evening from L&T Precision Engineering and Systems. Sir, a very good question. Actually, there are two things from which the CO2 emissions have been reduced. The first being the renewable energy that was used for the input energy consumed for the system that you correctly mentioned. We got the input energy as a renewable energy. Second was by eliminating the burner or the conventional based heating with the electrically infrared heating. So now the fumes or the smoke that is emitted from the burners is also completely eliminated and it is replaced from the electrically infrared heating system. This has been also reducing the CO2 as well as enhancing the safety as it completely eliminated the explosion hazard.
Okay, thank you.
Thank you.
Jose Carlos.
Yes, thank you, Willie. Well, congratulations for your project
Thank
and
you.
your presentation. You mentioned the impact on ESG, and you related to carbon footprint. Do you have some ESG reports that you show? You are an EPC company project. Can you please elaborate more if how did impact in your company having these results? Thank you.
Yes, sir. So our ESG report is openly available to along with the annual reports in our official website of Larsen and Toubro. And every year we have a target of reducing the carbon emissions by 10% year on year. And we have a target of carbon neutrality by 2030 and water neutrality by 2035. So this is what is the target at apex level. This can easily be obtained at the L&T official website, Larsen and Toubro website, in the annual reports. And now, as we all know that all the investors are very much focused on the environment part also, apart from the profitability part. So definitely we are working on that part also, that forefront also, the sustainability part. So that can be seen in the website, official website of the Larsen and Toubro. Right, sir.
Thank you.
Thank you, sir.
Yeah. I see that Mr. Narahari also has a question. So please go ahead.
Yes, sir.
One is, you said the laser sensor-based process has been used, and you're
Yes.
making a statement, it is completely errorless and repair-proof
Hmm.
system.
Hmm.
So how do you ensure that the repair-proof is a feature of this particular system? Because you are telling it is not having any failure probability. Is that the correct statement?
Right, sir. So I'll elaborate on the question, sir. So
Hmm.
as you correctly mentioned, it is a two-dimensional laser-based tracking system. It's a online and offline
Correct.
SIM tracking system. So basically,
Okay.
what we did was, you might have seen in the video also that there were some mock-ups that were welded initially before the start of the
Hmm.
system. So
Hmm.
based on the mock-ups, we have identified the groove imaging pattern, and that
Okay.
imaging pattern is being tracked by using the two-dimensional sensor. So you can imagine that there is a robot, and just
Hmm.
150 mm in front of the robot there is a laser sensor. So it
Hmm.
senses the groove on
Hmm.
live basis, and it gives the feedback to the actuator, and this torch behaves or actuates accordingly in order to adjust so that the
But
groove. Yeah.
yeah, but
Yeah.
your process capability chart doesn't seem to indicate that, because there is a wide degree of variability that I'm seeing.
Right, sir.
So I'm a little bit confused because of the process capability chart, especially the seam tracking sensor that
Yes.
you showed me.
Yes.
In that chart, I saw that there is a wide degree of variability. Why you are saying, it is able to track on target. So is it not contradictory a little bit?
Right, sir. Very good point that you have raised. So actually what we have found out is the variability of that seam tracker lies within 0.3 mm at the 2 sigma level,
Okay.
and 0.5 mm in 3 sigma level. So that is for GMAW welding, we are using gas metal arc welding. So for this kind of welding, the fusion area is such that 0.5 mm suffices the value of 99.36% of the occurrences. So that is why it remains fusible for all the cases that lies in our
But
range.
okay, agreed. So you're saying on target, okay?
Yes,
That's
sir.
what you're saying. You're able to get the
So,
things on target.
so you might have seen, sir, that there is a 0.06% rework also. So in some
Okay.
cases, there are rework still. We are finding out the root causes and we are trying to eliminate it every now and then as it comes.
Fair enough. Fair
Right.
enough.
Thank you, sir.
Okay.